Hey guys, Mr. Wilson here. Today we're going to talk about graphing quadratics. At the end of this video, you should be able to find the middle of a parabola, and you should be able to find the vertex of a parabola and determine if it is the high point or the low point. Okay? Alright, so a little bit of review. Graph y equals 2x squared minus 5 by creating a table of values. So before graphing, we should know this graph will have a U shape because of the squared term. So since we see that we have 2x squared, then we can see that, hey, this should be a parabola. That U shape is called a parabola. Okay, and we also know that the parabola is going to open up because the a value is positive. Value is positive, and this means that the parabola will have a minimum value. Okay, because it opens up, it continues up forever, but that means it has a lowest point. Okay, a minimum value. So let's make a table of values. Remember from our first semester on our table of values, we usually try to get some negative numbers, a zero, some positive numbers, just to see how our graph reacted in different places. And then we could just plug the values in to our equation to figure out how it was going to look. So we plug these values in now. I'll do it for the first two. Y equals 2, negative 2 squared minus 5. Negative 2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. And so we see that when x was negative 2, y was 3. And we could do that same thing repeatedly for negative 1, 0, 1, 2. We plug in negative 1, that's 1. 1 times 2 is 2. 2 minus 5 is negative 3. Plug 0 in here. That makes it easy because we have 0 minus 5, which is negative 5. And then if you remember, for parabolas, they had the same thing happen on the opposite side. So with 2 and negative 2 will be the same, 1, negative 1. Okay, and so now we can plot these points. 1, 2, 3, 4, 5. That's 0, negative 5. Negative 1, negative 3. Negative 2, 3. Okay, then we have 1, negative 3 down here, and 2, 1, 2, 3. Okay, so that's just plotting all those points. It's a U-shaped curve, U-shaped, okay. It's not a straight line. Don't use a ruler to make a parabola, please. Okay. Continues to go up forever and ever and ever. You'll notice that the minimum value is here. That's its lowest point. Okay, and these arrows at the end of our graph are symbolic that it continues on forever. We don't have to draw forever, but we know it continues on forever in the same way that it has been. Okay, now remember that the parabola is symmetrical, and that means that we can draw a line. There is a line that cuts the parabola in half. And this line is called the axis of symmetry. It'll be really important for us in graphing quadratics. Okay, so we did that in the first semester, graphing parabolas, being able to kind of see what their characteristics are just by looking at the equation. And this, we're going to build on that in this chapter. So let's graph y equals x squared plus 6x plus 5 by creating a table of values. So if we were to continue in how we did it before this new information we're going to learn today, we would plug in some values, negative 2, negative 1, 0, 1, 2, plug them in, and then just see what we get out of it. So we have negative 2 squared. Again, I'll do this first one just to do it, but I'll talk through the rest of them because space is kind of limited. So we have 4 minus 12 plus 5, and that ends up giving us negative 3. Okay, so when x is negative 2, y is negative 3. Okay, so when x is negative 2, y is negative 3. We can do that same thing for all of them. 1 squared minus 6 is negative 5. plus 5 is going to give us 0, 0. We're doing that right. That gives us 5. 1 plus 6 is 7. 7 plus 5 is 12. 4 plus 12 is 16. Plus 5 is 21. If you notice, with these points now, when we plot them, we have -2, -3. That's 1 point. We have -1, 0. We have 0, 1, 2, 3, 4, 5. We've got 1, 12. And you'll notice that, hey, this doesn't give us a U. Remember up here we said, hey, we know this is going to be U-shaped because, well, it has a squared term. And the reason that this doesn't give us a U is because we didn't find the middle of the graph, or middle of the parabola. Okay, the middle of the parabola is where the parabola changes directions. Okay, the point at which this occurs, the changing of directions, is called the vertex. So notice in our first graph, kind of lucky that the problem that we had is that 0, our vertex was there when x was 0 and y was -5. So we got the U shape. In this case, our vertex isn't there. Okay, and so what we're going to have to do then, and what we're going to learn today, is we're going to learn how to find the axis of symmetry. Okay, now the axis of symmetry always goes through the vertex. It always goes through the vertex, and so as we continue now, we're going to learn how to find the axis of symmetry so that we always find and are able to show our U-shaped parabola. All right, flip to the back with me. Okay. Okay, so therefore, the first thing you should do, okay, we kind of messed up this last time on this last problem. We're not being able to find our U-shape because we did not do this. The first thing that we should do all the time when graphing quadratics is find the axis of symmetry. Okay, and the coordinates of the vertex. And that's what we're going to learn today, finding the axis of symmetry and the coordinates of the vertex. Okay, so we're not going to do everything because this will just be the important, I'd say the most important part of graphing, even though every aspect of graphing is going to be important. This is the most important part, finding the axis of symmetry, finding the coordinates of the vertex. That makes the rest of the problem a lot easier. Okay, the formula for finding the axis of symmetry. X equals opposite B over 2A. And you'll see this pop up a couple times through this chapter, but we'll use that here for graphing. Okay, the axis of symmetry is a vertical line. Okay, remember we said that the axis of symmetry is the line that will cut the parabola in half. The parabola will always look like a U or a hill, even if it has a -a. But the axis of symmetry will always be vertical. Okay, and that's why the formula starts with x equals. Okay, from our graphing chapter, our linear graph chapter. Okay, the a and the b come from the general form of quadratic. Remember that was ax squared plus bx plus c. That's the general form of quadratic. And since the axis of symmetry goes through the vertex when you find the axis of symmetry, you have also found the x coordinate of the vertex. Okay, to find the other coordinate, use your x value and plug it into the equation. Okay, once we have that x value, we'll plug it into the original function and we'll get our answer. All right, so if you follow along with that, great. If you didn't, hopefully these we'll go through it a little bit, or don't hesitate to replay that or watch an example and then replay it. Okay, so here we go. Again, we're not going through the whole graphing part. We're going through the foundation of it to find the axis of symmetry and the coordinates of the vertex here. So for this problem, we have 2x squared plus 8x plus 11. Now I'm going to start off, and you don't have to do this for a long time, but it might be helpful, especially for the first day, starting off and identifying your a, your b, your c. I'm going to start and find that. Remember, a is the value before the x squared, b is the value before the x, and c is the value by itself with no variable by it. Remember, the sign in front of it is also included. In this case, all these are positive. So first things first, I want to find my axis of symmetry. that will be x equals opposite b, so b is 8, opposite b over 2a. So I'm going to say opposite 8 over 2 times 2. Okay, so that's negative 8 divided by 4, which is negative 2. So my axis of symmetry is x equals negative 2. Remember, x equals for us is not us solving an equation. This is the equation of our vertical line. Okay, and now we find the vertex. We will find the vertex by plugging this x value in to our function. So I'm going to do that right above here. I have 2 times negative 2 squared plus 8 times negative 2 plus 11. Negative 2 squared is 4. 4 times 2 is 8. Minus 16 plus 11. So 8 minus 16 is negative 8. Negative 8 plus 11 is 3. So our vertex then, we already have our x-coordinate. Remember, our x-coordinate is the same value from our axis of symmetry, because our axis of symmetry has to go through the vertex. And then our y-coordinate is whatever this is. And so we added it up. We found out that it was positive 3. And there's our vertex. So once we have our vertex, then we'll be able to go on from there to find the rest of our graph, and we'll talk about that in the next notes. Okay? All right, let's look at number 2. Okay, and this is where identifying your A, your B, your C might be really helpful for some of you guys. Remember, A is the value that comes before x squared, so 5 is A. Now, this is where people trip up. B is not the second value. B is the value that comes before x. Now, where do we have just x in this problem? It's not here. And so that means that B must be 0. Okay, and then C is the value that doesn't have a variable by it, which is negative 8 in this case. Okay, so I identified A, B, and C, and that will help me with this next part. X equals opposite B, which is B is 0, over 2A. So 2 times 5 or 10. So 0 over anything is just 0. Our axis of symmetry then is that x equals 0. Now we'll have to find our vertex. Remember, we already have our x value for our vertex. It's whatever the axis of symmetry is, whatever that value for the axis of symmetry is. And then we can plug that into our formula and see what pops up. So 5 times 0 squared minus 8. That's 0 minus 8, or negative 8. And so there's our vertex. Negative 8. Let's do one more. Again, I'm going to identify my A value, which is 1/2, my B value, which is negative 6, my C value, which is 13. Okay, I know my axis of symmetry will be opposite B. So B in this case is negative 6. The opposite B will be positive 6 over 2A, 2 times 1/2. So 6 over 1, which is just 6. X equals 6. That means the x-coordinate of my vertex is 6. And now to find where that vertex, that y value of our y-coordinate for the vertex, we plug 6 into our equation. So y equals 1/2, 6 squared, minus 6 times 6, plus 13. Okay? Remember to do your order of operations correctly, guys. If you have a calculator, you can use it. If not, remember to use the PIMDAs. So 6 squared is 36, half 36 is 18. 6 times 6 is 36, plus 13. So what we have here then is 31 minus 36, or negative 5. And that's our value for our vertex. Our coordinate for our vertex, sorry, not value. All right, so there we go. That's us finding the axis of symmetry and the vertex. All right, now let's look at some applications for this, okay? So this can be used in kinetics in real world, and so let's look at some story problems that use the vertex and the axis of symmetry to solve actual problems. So a tennis player hits a ball over the net. The ball leaves his racket 0.5 meters above the ground. The equation h equals negative 4.9t squared plus 3.8t plus 0.5 gives the ball's height h in meters at any time, t seconds. What direction will the parabola open? Y. Okay? So looking at this problem, we can see that the parabola will open down. Okay, in this case we know the parabola will open down because the a value is negative. Okay, remember our refresh problem, we said well, we could tell it's going to open up because the a value is positive. Well, now the a value is negative, we know it's going to open down. Okay, that means that the parabola will have a maximum point. So if you think about it, the parabola is opening down, right? Then we know that, hey, there's a point where it reaches its highest point. It's maximum. Okay? Now the question is asking, when will the ball be at its highest point? So let's think about this as a graph. Okay? And what we're going to have is we're going to have height and time. So this question is asking us when, so it's asking us about time. And notice on our graph in science and math, time is usually the independent variable. Our time is on the x axis. So it's asking us, hey, when is it going to reach this point? And I'm drawing this line because I want you to see that it's asking us to find the axis of symmetry. Asking us to find the axis of symmetry and basically saying, hey, what's the value of x at its highest point? Remember, the maximum is the vertex, so we can find that by using x equals opposite b over 2a. Remember, we get these values from our formula here. So x equals, our b is 3.8, so negative 3.8, over 2 times negative 4.9. Okay, so then I can do this, and I'll need a calculator for this, so I'll pop it up. Hopefully get it out of the way a little bit so we can see it while I'm still doing this. So I'll have negative 3.8, 3.8, make sure it's negative, divided by, and I'll put this in 2 times negative 4.9 is negative 9.8, divided by 9.8, make sure it's negative, and that gives me this great number here. So x is 0.38, I'll just say 8. Okay, 0.388. Now, important for me to understand what I'm actually measuring or what I'm saying. 0.388 seconds. Okay, because that's what it's being measured in. So, in about half a second, a little less than half a second, the tennis ball will be at its highest. Point. Okay. Now the second question says, hey, how high will it be? Again, let's revisit this graph and make sure we know what the graph is measuring. It asked us, now we know when the ball will be at its highest point. It'll be in 0.388 seconds. And now it's asking how high it will be. So it's asked us about the time already, which we knew that time was the x value. Now it's asking us about the height. And now, remember, height is the y value. And since we know the x value, and when it's going to be its highest, then we can just plug that into our equation, 0.9t. And instead of using t now, we're going to say 0.388, because that's the time that we really care about. 0.388 plus 0.5. Alright? So that's how we'll do it. Notice that that's going to give us a height, and that height is going to be in meters. Okay? Just to make sure you've made it all the way through these notes, please evaluate that. Tell me how high that ball is going to be, and bring it in as evidence of your completed notes. All right? See ya.